Hi everybody. In this video we are going to discuss about implementing the insert beginning function. We have already done the basic stuff required for implementation in C++. What we have done is we have created a structure to represent a node in the linked list. So there are obviously two members, one is the data part, other one is the address part, and we name the data part as data and address part as next. And then we represent the list by using a class. So the name of the class is list, and there is only one member of the class, that is the head, okay, and it is going to be the pointer of what is pointer of the node. So we declare it as node star head. It is in the private section and we are not going to directly access it from outside. And in the public section we have got constructor and then SMT. Constructor's role is to do the job of creating a list. So what is meant by creating a list is we are going to create an empty list, okay. So empty list in the sense the head part will be equal to null. That's what we are going to do. As we already know, memory will not be initialized by C and C++. So we initialize it in the constructor. So we are going to tell head equal to null, and we have returned the isEmpty function. How does isEmpty function works is it will check whether head is equal to null. If head is equal to null, it is going to return true and it is going to return false otherwise. Bool is a morphed data type in C++. It is allowed. So we are having the return type as bool, and we can use true and false in the case of C++. So let us continue the implementation. The next function which we are going to think about implementing is the isFull function. Whether it is possible to implement the isFull function. Yeah, just recall what did we do in array implementation. In array implementation we had like capacity as well as the number of elements where also the members, and we were checking if the number of elements in the list is equal to the capacity. If it is equal to the capacity, then we are not going to have any more memory. So we have to declare that the list is full, okay. So we have to return true when number of elements is equal to capacity. But in the case of linked list, there is no chance of doing that, because when you look at it, the capacity is equal, the capacity of the list will be equal to the capacity of the system's memory. Generally heap is used for dynamically allocating the memory. So it depends on the heap size which is getting allocated. So there are much more criteria like what is your RAM size, what are the other applications running, and so on. Since we do it dynamically as required. Okay, so how you can identify that you cannot proceed or you cannot add any more nodes? You can check it only during the node creation. Until that it is not possible to check, and it is not possible to write it as a standalone function. So we cannot implement isFull for linked list. And next what we are going to do is we are going to write the insert beginning function. We will start from insert beginning and write insert at a given position as and the insert end as well. But when you look at the steps involved, one common step that is involved is creating a node, right? You have to create a node, you have to put the new data in the data part, and you have to make the address part as null. This is common for all the insertion algorithms, insert beginning, insert end, and the insert at a given position. For all the three this is going to be common. So what we are going to do is we are going to make it as a separate function itself, okay. So we are going to write a separate function create node, and you will do these things. You will put the data in the data part and make the next part as null. So when you look at the parameter that is coming for this create node, it will be data, okay. And you are going to dynamically allocate the memory for the node, and if address is so you are going to use new. In C++, how will you allocate memory? Dynamically using the new operator, okay. So we will allocate and check what is being returned. Generally new operator returns the first byte's address, okay, that is getting allocated. We will check what is getting returned. If it is null, then we can understand that there is no memory at all. So you have to return null, okay, immediately. Otherwise a node is getting created. So put the data that has come as argument in the data part, and you have to make the next part, okay, as null, okay, and you have to return the address of the node created. That is also important, right? So let us try to implement this create node, and this create node, when you look at it, actually it cannot be part of the linked list. It should be outside the linked list, of course, because it is not going to operate on the list, right? Rather this is going to be a common operation. So let me put it in the global part, that is outside the class. That's what I mean by global. So return type is node star, and yeah, you have to create a node, and no, it will take only the data. Okay. And what does the algorithm tells? Algorithm tells dynamically allocate the memory. Okay. So let us tell node star new node. Let us tell node star new node, and new node is equal to new node, right? This is how we will allocate the memory, and as per the algorithm you have to check if the address returned is null. Okay. If new node is equal to null, then you have to return null. Okay. Otherwise what you have to do, no need to put else, you have to put the data in the data part. Okay. You have to put the data in the data part of the new node, and you have to make the address part of the new node as address part is here referred as next equal to null, and you return the address of new node. One point that we have to remember is, since we are doing dynamic memory allocation, this memory will not get freed, it will not be given back to the system even when we move outside the function. Okay. Since we are using new, till we use delete for this particular memory, it will not be given back, or else you should be careless, you will not deallocate. In that case the system will take care after your program stops execution. So till the program is executing, this memory is yours. Okay, irrespective of whether you are leaving this function or not. Okay. So create node is done, and we are going to now write the next is we are going to write the insert beginning function. So what can be the algorithm for this insert beginning function is, you have to insert it into the list. So two things are required for doing this operation. One is the list in which you are going to insert, other one is the data what you are going to insert. When I tell I am going to insert the data, I need a node, okay, in which the data is being placed, right? So for that I will be calling the create node function, and that function will be giving the address of the newly created node, okay, that will be given to me, and I will check if the value returned is null. If the value returned by create node is null, then you will return false, because my insert beginning will return bool value. It will return true when the operation is successful, and it will return false when it couldn't perform the operation. Okay. So if null is returned by the create node function, then you will return false. Otherwise you will make the next part of the new node to, okay, so what will I do? Actually this is the new node, right? This is the new node created, and let us assume that already there is a list. Okay, let us assume that there is already a list with two elements, 10 and 15, and head will be pointing to the first node of the list. Now what should I do? I want to insert that in the beginning. So what do I mean is, I want this to be the first element, or this node should be the first node, right? So I have to connect it. This should become the second node, this should become the third node. Totally after insertion there should be 3 nodes in the list, isn't it? Right? So what I will be doing is, I will be trying to connect this. Okay, that is the next part of the new node should contain what? The address of the first node. Where is the address of the first node? Address of the first node is in head. That we have to make it. And then what does the rule tells? The rule tells that head should always point to the first node of the linked list. So move your head from here. Hereafter head should not be here, rather it should be pointing to the first node, right? So these are the steps that we have to follow. Make next part of the new node to store head, okay, and make head to point to new node. Let us do that. and this will be a member function. Okay, let me put it as a member function. Yes, I will tell the return type is bool and insert beginning is the function name. List is going to come implicit as it is object oriented programming, so I am going to just pass the int alone, right? And then I am going to implement it bool, right? It's part of a list, and we'll be writing insert beginning, right? Int data. Okay, and then what we have to do is we have to declare a pointer. We have to declare a pointer, and then you call the create node function to create the node, for which you will be just passing the data alone, right? And you have to check whether the value returned is null. If it is equal to null, then you return false. Okay, otherwise you are going to proceed in this. What you have to do, you have to now establish these connections. One thing is, new node's next part should hold the address of the first node, that is the head. Okay, so new node's next part is going to have head, right? And head, and one more thing is, head should now point to the new node, right? So head is equal to new node, right? And you are going to return true, because this is successful if there is memory, so you are going to return true. Okay, so this is your insert beginning. We have to check whether all these are working fine. If we have to check, then we need a print list function. A print is a basic requirement for checking whether the data structure is getting properly implemented or not. So we have to write the print. I will make it as a separate part